I'm Atsushi Masuko, former Director General of the Bureau of Waterworks for the Tokyo Metropolitan Government. Today, I would like to share with you energy consumption reduction by direct water supply in Tokyo. In this presentation, I would like to talk about why and how direct water supply is adopted and contributes reducing power consumption in water supply system. Before I get into my talk, I'd like to give you a brief overview of Tokyo water services. Tokyo is a city of 13 million people and is one of the largest cities in the world. The total supply capacity of its facilities is about 7 million cubic meters per day. As we know, it is better to intake water at higher elevations, but only 20% of Tokyo's low water is drawn from high elevation intake points. The remaining 80% is from low levels, only a few meters above sea level. Therefore, pressure and water supply stability depend greatly upon pump operations. One of Tokyo Water's most remarkable points is its ability to achieve both an extremely low non-revenue water rate of 4% and higher supply pressure. Water loss is very closely related to energy loss, resource loss, and money loss. On the other hand, water pressure is essential to maintaining water security in distribution systems and improving customer service. We are striving to reach a balance between the conflicting goals of maintaining higher pressure and leakage reduction. Here, I would like to describe the pressure standard in Tokyo. The average water pressure is 0.32 megapascal, and the minimum is 0.2 megapascal. This allows for a direct water supply to every three-story building. Additional pressure standard concepts are as follows. If the pressure is sufficient, buildings taller than 3 stories are supplied directly without using pumps. If the pressure is not sufficient for a building's height, a direct booster pump system is installed. Proper distribution requires 0.6 kilowatt-hour per cubic meter in Tokyo. Through my research on receiving reservoir supply, I determined that customers also consume 0.6 kilowatt-hour per cubic meter to lift the water. Now, shorter buildings 4 or 5 stories tall are permitted to connect directly where pressure is sufficient. Customers do not need receiving reservoirs or lift pumps. Taller buildings must install booster pumps to supplement the pressure. These pumps consume less power than traditional lift pumps from the reservoirs. Tokyo Water's strategy for service connections changed in 1995. Before 1995, all buildings 3 stories or taller installed receiving reservoirs. The graph on the right shows that only 7% of newly built 3+ story buildings now use reservoirs. The remaining 93% have adopted the direct water supply system, which means 3,000 cases in 2017. Existing buildings have also started to convert their supply systems from reservoir type to direct type. A major regulation change in 2004 further promoted these conversions. The change was that booster pumps do not need to be installed where pressure in the network is high enough. There are now approximately 3,000 conversions of existing buildings annually. Receiving reservoirs were equipped in most buildings 3 stories or taller in 1995. Today, the number of buildings with direct supply or direct booster pump systems is comparable to the number with a receiving reservoir system. This picture shows you an example of a recent conversion at an existing shorter building. Before the conversion, you could see a receiving reservoir in front of the building. In the right-hand picture, that reservoir has been moved and a space facing the road has been created and converted to bicycle parking area. Please let me summarize the merits of direct water supply. First, such systems save energy. Second, water is not exposed to the air, so deterioration risk is minimized and quality is preserved. Third, there is no need for receiving reservoir maintenance. This also saves not only energy, but also costs and labor. Related to this, the initial cost and maintenance cost are much lower. The last merit is related to space in megacities. Conversion means space is created and used more efficiently. Please let me describe Tokyo's optimal supply pressure. This picture shows one approximation of the total power consumption in the distribution facilities and in customer water lifting systems. As shown on the left, when water suppliers lower supply pressure to save power, customers have to make up for that in their buildings. However, it is very important to minimize overall water supply power consumption. This shows how providing pressure capable of supplying a 3-story building is a better choice in Tokyo, as it reduces the total power consumed. Here, I would like to emphasize the importance of uninterrupted water pressure in distribution pipes. Uninterrupted water pressure in pipes enough to block deterioration from outside through leaks or taps is necessary to deliver high quality and safe water to customers. Moreover, if the pressure is not high enough, water users must intake water with suction pumps. This causes serious pressure drops within the system, and a vicious cycle of low pressure and suction begins. With sufficient pressure and supply capacity, water is supplied directly to customers without the need for receiving reservoirs and lift pumps, which waste energy, use up space, and reduce water quality. Those reservoirs may also be at risk of deterioration and even could be subject to attack with poison. Taller buildings can have direct booster pumps installed and operated safely with proper controls and safe fittings. Now that we have looked at pressure, let's turn to leakage. Leakage control is a very common issue. It is also one of the most important aspects related to energy loss, resource loss, and money loss. If you reduce leakage by a certain amount, power consumption can be reduced by a comparative amount. This graph shows you the change in the materials used to make pipes, including the switch to ductile iron and stainless steel, and the reduction in the non-W water rate. 50 years ago, its rate was 40%, but the current rate is only 4%. These changes not only reduced the non-W water rate, they also helped strengthen the pipe networks. Thank you very much for your attention.